In this video, we have our slightly different title selected, Happy Problems. Same initials, but we're trying to do the more interesting ones as always because I feel like we did 2 example videos. The kind of basic problems should be pretty, October, please don't scratch that. Similar to the example problems video. So let's just start with number 405. Number 405, don't do that. Don't do that, computer. Number 405 says, explain what's wrong with this integral. I'm not going to write the answer down. I just want to talk about it with you. Well, what do you think? One of the ways to look at this integral is the area under the curve of 1 over the square root of 1 minus t squared from 1 to 2. Let's look at that. 1 over the square root of 1 minus t squared from 1 to 2. Right, we're going to have to fix the y-axis so that we can see the whole function, right? We're going to have to see that. Wait a minute. What's going on? Let's go from 0 to 2. And let's maybe zoom back in a little bit. Oh. The area under this function from 1 to 2? Well, that's bananas, Jason. This function has a vertical asymptote at 1. This function is not even defined from 1 to 2. This is tomfoolery. This is balderdash, poppycock. All right. Watch out for the region of integration. It does matter. This function, it's okay that this function is not defined at 1 for the area, but certainly anything bigger than 1 is a real big problem. And even 1 is a case-by-case basis. So that's wrong. That's what's wrong with the integral, right? This function is not defined from 1 to 2. There is no area under the curve from 1 to 2. This function can only be integrated from -1 up to 1 in any subregion there. Okay, so watch out for that. 411 says compute the antiderivative. Okay, antiderivative of inverse sine of t dt all over in square root of 1 minus t squared. So it almost looks like just a regular old inverse sine thing, but we already have an inverse sine up here. So if we didn't have this guy, it would just be inverse sine with that formula. And that's kind of a flipped way of seeing the solution. It's going to be a u substitution here. Because notice, if this is our u, well, we already have its derivative. Right? Look at this. And this is one of the things that like experience really helps with. If that's our du, then the derivative of u with respect to t is 1 over the square root of 1 minus t squared. So du is just dt divided by the square root of 1 minus t squared, which, by George, we've got. This is just u du. It's that easy. Like a lot of math, right? If you see it, it's easy. If you don't, wait, hold on, watch this, watch this. If you see it, it's easy. And if you don't, thumbs down. Haha, totally flawless. I didn't have to keep you waiting at all. Timing is everything in comedy. Okay, so now we just use the power rule. And then sub things back in. U is inverse sine plus c. And again, as a reminder to everyone, you can check your answers in the back of the book. To the odd numbered problems, you can open it in a new tab. You can open it in an old tab. We're looking at 411. And we're hoping the textbook agrees with me. 1/2 inverse sine of t squared plus c. It jumped to the bottom, but before it jumped to the bottom, it confirmed our answer was right. And we can also check our answer by taking the derivative. This is going to be a sad homework problems video. It's not even going to be 3 hours long. One more. 431. Compute each definite integral. The integral from 0 to 1/2 of sine of inverse tangent. Okay, now we're getting somewhere. Now we're getting something fun. Sine of, whoa. Sine of inverse tangent over 1 plus t squared dt. Don't get too excited, guys. I know it looks kind of fun, but it's really kind of boring again. Because it's the same idea, right? It looks like we kind of have an inverse tangent situation going on. We have 1 plus t squared. But we also have an inverse tangent somewhere going on as well. That's just going to be another u substitution. I'm sorry, it's not harder. The u is going to be inverse tangent. The derivative of u with respect to t will be the derivative of inverse tangent. So du is just 1 over 1 plus t squared dt. I'll do some extra steps on this one just to really be very clear on this. Let's rewrite it before I change my limits as the sine of inverse tangent of t times 1 over 1 plus t squared dt. Again, I haven't changed anything. All I did is said, well, this numerator can be written out in front. And now we can do the u sub. If t is 0, u is the inverse tangent of 0. The tangent of what equals 0? And the answer is 0. Well, if t is 1/2, then u is the inverse tangent of 1/2. The tangent of what is 1/2? I don't know. I'm not crazy, right? That's not a nice number. Inverse tangent of what is 1/2? Pretty sure that's not a nice number. So we're going to write arctan of 1/2. If I'm crazy, tell me, please. And then notice that this guy is just du. We just get the sine of u times du. And we're almost done. What's the antiderivative of sine? Negative cosine. And remember, we don't have to put things back in terms of x because we already substituted our limits of integration. Ooh, this one might be kind of fun, actually. Let's see where it goes, okay? I'm getting a little excited, a little bouncy. That's why I have to stand up when I record these videos. I can bounce up and down. So this is just negative cosine of, whoa, I am really going to town here. Arctangent, it's either arctangent or inverse tangent. You don't have to write both. You don't need the exponent like I had. These things are the same. Anyway, cosine of inverse tangent. We should really... Inverse tangent is the same as arctangent of 1/2. And then minus a negative. So we can just write plus cosine of 0. All right, so cosine of 0 is 1. But let's look at this other guy. Yeah, I might be able to have some fun with this. Might not. It still might just be decimal approximation thing. So let's see. Cosine of 0 is 1. Question is, can we evaluate cosine of arctan of 1/2? So we go and remember our trig. We give it an attempt. Maybe it won't work, but we give it an attempt. And say, okay, the arctangent takes in a ratio and gives us an angle. Then we have to take the cosine of that angle. So arctan of what angle gives us 1/2? Well, let's draw a little picture. Since it's positive ratio, we know we're going to be in the first quadrant. We're just going to draw a little triangle. Tangent of what? Oh my goodness, I'm losing it. Tangent of what is 1/2? Well, it's going to look like this. Because tangent's opposite over hypotenuse. There are infinitely many triangles. They could be longer, but they're all similar triangles with these ratios. So the question is, what's the cosine of that angle? Adjacent over hypotenuse. Ooh, we can do this. I lied to you at the start. This is a fun problem. Good. I'm glad I found it. Okay, so, oops. So what is that hypotenuse? Well, a squared plus b squared equals c squared. It's going to be the square root of 5. So cosine of arctangent of 1/2 is just the cosine of this theta down here, which is adjacent over hypotenuse. Even though I'm almost positive we can't find this exactly, we can find the whole thing exactly, eh? We get 1 minus 2 over square root of 5, which is perfectly fine for me. I can guarantee the book is not going to write it this way. They probably rationalize the denominator. They probably combine the fractions as well. Let's just see what they do. 431. Oh, we already had an answer key tab open. You can't see it though because it's cropped. Oh, so remember when I said I can guarantee? I lied. I can't guarantee anything. Their answer is the exact same as ours. 1 minus 2 over root 5. I'm surprised. They usually like the people who do the answer key are weird, very different people, I guess, and that's why. Oh, there you go. That's this section. That's chapter 1. We're done with chapter 1. Hope you're ready to go on to chapter 2, where we applicate, apply all this stuff we've done in chapter 1. Let me know if you have questions, and have a good night, day, morning, whenever. I always misclick. I don't hit the stop recording button, and it's just all this. Bye.